Good evening and welcome to Lecture 12. This week we'll discuss security, security policies, security on web client computers, security in the communication channels between computers, security on web computers, and we'll look at who promotes computer, network, and internet security. A proper use of password protection is an important element in maintaining security. Most people are unwilling to remember numerous complex passwords and change them often. Password management tools are popular solutions for maintaining multiple complex passwords. This requires a single master password for access. However, this becomes a weak link when hackers access master passwords. Encryption is an important safeguard to help address attacks. Individuals and businesses have had concerns about security ever since the internet became a business communications tool. The concern increases along with the steady increase in sales and all types of financial transactions. Modern computer security techniques were developed by the U.S. Department of Defense. They published the Orange Book rules for mandatory access control. Business computers initially adopted the military's security methods. Networks and other factors have increased the number of users accessing computers. And computers now transmit very valuable information. The need for a comprehensive security risk system of controls is now more important than ever. Assets need protection from unauthorized access, use, alteration, and destruction. Physical security includes tangible protection devices such as alarms, guards, fireproof doors, security fences, safes or vaults, and bomb-proof buildings. Logical security is protection using non-physical means. A threat is anything posing danger to computer assets. Countermeasures are procedures that recognize, reduce, and eliminate threats. The extent and expense depends on the importance of the asset at risk. Risk management model for security has four general actions based on the impact, in other words, the cost to the organization of a loss, and the probability of the physical threat. It's applicable for protecting internet and electronic commerce assets from physical and electronic threats, protecting against eavesdroppers that listen in on or copy internet transmissions, crackers or hackers that obtain unauthorized access to computers and networks. Companies must identify risks and determine how to protect the assets and calculate how much to spend. And here we see the risk management model in a Gartner-like quadrant. Low probability and low impact threats are basically ignored. Low probability but high impact are where you develop an insurance or backup plan. High probability but low impact you contain and control, and then high probability and high impact you prevent. So let's go over some terminology in the field of information or computer security. Secrecy refers to protecting data against unauthorized disclosure and ensuring the data source is authentic. Integrity is preventing unauthorized data modification. Integrity violation occurs, for example, when an email message is intercepted and changed before reaching a destination. Often integrity is the result of a man-in-the-middle exploit. Necessity refers to preventing data delays or denials. A security policy is a written statement of the assets to protect and why you need to protect them, who is responsible for that protection, and acceptable and unacceptable behaviors in the organization. Security policy will address physical and network security, access authorizations, virus protection, and disaster recovery. There's a couple of steps to create a security policy. First, determine which assets to protect from which threats. Determine access needs to various system parts. Identify resources to protect the assets, and then collate all this into a written security policy. Once a policy is written and approved, resources can be committed to implement the policy. A comprehensive security plan protects the system's privacy, integrity, availability, and it authenticates users. All security measures must work together to prevent unauthorized disclosure, destruction, or modification of assets. The main points in a security policy are authentication, who is trying to access the site, access control, who is allowed to log on to and access the site, secrecy, who is permitted to view selected information, data integrity, who is allowed to change data, and audit, recording who or what causes specific events to occur and when they occur. Let's look at viruses, worms, and antivirus software. A virus is software that attaches itself to a host program and causes damage when the program is activated. A worm is a virus that replicates itself on computers that it infects, and it spreads quickly through the internet. A macrovirus is a small program that is embedded in a file. The first major virus was I Love You in 2000. It spread to 40 million computers in 20 countries and caused an estimated $9 billion in damages. The 2001 Code Red and Ninda were multi-vector virus worms. They entered the computer system in several different ways and caused billions in damages. In 2003, a new version of Code Red checked for antivirus software, so it got into countermeasures. Antivirus software detects viruses and worms. It deletes or isolates them on a client computer. In 2008, the Configure virus, which continues to be a concern because it can reinstall itself after removal. In 2011, a new and more Trojan combinations of viruses were encountered, and some targeted bank accounts. 2013, a new form of virus emerged, and that was ransomware that encrypts files and demands payment for keys to unlock them. The perpetrators got away with more than $3 million, and in 2015, a new version was developed that attached itself to games. Companies such as Symantec and McAfee track viruses and sell antivirus software. Data files must be updated regularly so that the newest viruses are recognized and eliminated. Some web email systems, such as Yahoo Mail and Gmail, automatically scan attachments before downloading. Digital certificates. A digital certificate is an email attachment or program embedded in a web page that verifies identity. It's used to execute online transactions, send encrypted email, and make electronic funds transfers. A certificate authority issues digital certificates to organizations or individuals, and these certificates have 6 elements: the owner's identity and public key, validity dates, serial number, issuer name, and digital signature. The key is a long binary number used with an encryption algorithm to lock protected message characters. Identification requirements vary between certificate authorities. Usually it's something like a driver's license, a notarized form, or fingerprints. More stringent rules were adopted in 2008 after hackers obtained falsified digital certificates. Annual fees for a digital certificate run from $100 to more than $1,000. Digital certificates expire after a period of time. This provides protection by requiring credentials to be resubmitted for evaluation. A steganography is the process of hiding information within another piece of information. It can be used for malicious purposes. It provides a way for hiding an encrypted file within another file. The casual observer cannot detect anything important in the container file. A 2-step process occurs where encrypting the file protects it from being read, and then steganography makes the encrypted message invisible. Al-Qaeda uses steganography to hide attack orders. Here we see the requirements for secure electronic commerce: secrecy, integrity, availability, key management, non-repudiation, and authentication. And of course, this chart that gives the meanings for each one of those terms is from the book. Here's a list of some early computer viruses, worms, and Trojan horses. And continuation of that list, year 2000 with the I Love You, one of the first massive viruses that infected the internet. And then coming down to the Storm, Trojan Horse, Leap, Zotab, and Sasser viruses also. And then we see some of the more current ones, Stuxnet, and Crypto Locker, Testacrypt. Here's a comparison of hash coding, private key, and public key encryption. And we're going to discuss that next. But here's a graphic that shows how they're conducted. A hash function takes a particular input, and then it will create a hash key for that. Private key encryption then will take a plain text, and it will encrypt it using the values of the key, send the encrypted message, and that key has to also be known by the receiver, who uses it to decrypt the text back, the encrypted text back into the plain text. This is in contrast to the public key encryption, where you take a plain text message, you use the recipient's public key to encrypt it, then you send the message encrypted, and the receiver uses their private key to decrypt it. And here's establishing an SSL session and sending and receiving a digitally signed message.